Hello, I'm Kaviraj and I will be presenting the study titled Great Apes Anticipate That Other Individuals Will Act According to False Beliefs. The study shows that apes possess a form of theory of mind which allows them to understand beliefs. The experiment is an anticipatory looking test to show that apes possess similar kind of cognition to that of humans and that apes do not need conceptual reasoning about the mental states for implicit understanding. Now let's demonstrate one experiment shown in the study. An ape will observe a room separated from a glass pane. The room will have two doors as exit and two haystacks as hiding spots. The disguised ape will stay in the middle of the two haystacks. As the human enters the room, the disguised ape will hide under one haystack, let's say the left one. The human will observe its location and the human will go out of the room. The disguised ape will go out of its hiding spot and will hide in the other haystack and eventually go out again from its hiding spot to go out completely from the room. When the human gets back in the room with a stick to hit the hiding spot, he will stand in the middle of the two haystacks. The eye gaze of the ape behind the glass is then tracked to see if it can anticipate the false belief of the human. The human falsely believes that the ape is on the left, and if the gaze of the ape is on the left, it means that the ape can anticipate the false beliefs of the human. This experiment is repeated 30 times with different species. To model the experiment, I have used a Bayesian network with three nodes, one for the action of the ape, one for the belief of the human, and one for the true location of the disguised ape. For my implementation, the disguised ape will stay in one of the haystacks and will not go out of the room. The location of the disguised ape will be changed randomly, and therefore the belief of the human can also be true as compared to the study where the belief was always false. To implement this, I will create a ROS package with three nodes, scripts, and one compute anticipation service that will implement the Bayesian network. Here you can see the flow of the ROS package where the scenario node will publish the variables to which the ape node will subscribe. The anticipation is retrieved from the Bayesian node and is published. After 30 experiments, an aggregated count will be published for visualization. I will demonstrate the program now. After launching the nodes, you will see an activity plot where the true location, belief of the agent, and anticipation of the observer are plotted. The activity graph displays the nodes and topics and service of the program. After 30 trials, a bar plot will be displaying the number of correct anticipation, where you can see the number of correct anticipation is higher than the uh, number of wrong anticipation. The bar plot will refresh after 30 trials is completed. Comparing the results, 20 out of 30 trials are correct anticipation and therefore matches the result from the paper. I can conclude that the Bayesian model performs well to simulate the anticipation based on the belief of an agent. I thank you for your attention.